Share the screen, push this thing, push this thing. Sorry, that always takes a while. Okay, I think we're in business. First thing I'll talk about is the quiz. So the quiz is now past due. You had to turn it in as of what, 12:10, a few minutes ago. So I can go over it now. And quizzes in general from here on out are individually done. I'll grade you individually, not as a group. Now the first quiz, okay, let you discuss it with each other and as a group, and you're only responsible for one question. But now everybody's responsible for every question, which means when you submit your quiz early, as some of you did, I can tell you right away, you know, how you did. Okay, f of g of x, so f of 11x plus 30, 3 times 11x plus 30 minus 10, a little bit of algebra, 33x plus 80. Then g of f of x, g of 3x minus 10, 11 times parentheses 3x minus 10 plus 30, clean up the algebra, 33x minus 80. F of x, f of 3x minus 10, 3 times 3x minus 10 minus 10, a little bit of algebra, 9x minus 40. And finally, g of x, g of 11x plus 30, 11 times 11x plus 30 plus 30, a little bit of algebra, 121x plus 360. Okay, so that's quizzes. Most quizzes are going to be like that. So there's not much of a reason why you can't get, you know, full credit on just about all the quizzes. Number one, you can talk about it with others. Number two, it's not something that's due right away. You have the weekend to work on it, and it's open book and open notes. So you know, you should be able to do pretty well on quizzes in general. Okay. All right, so that's that. And now here we are. Okay, so I was done with 1.4, so I'll start 1.5. Okay, and 1.5, a little bit of a change. I'm throwing out 17 and 19. Not sure if I said one or the other or both, but for 1.5, skip 17, skip 19. Okay, you're not responsible for 17, you're not responsible for 19. Okay. And what I was hoping for is if I finish early, okay, again, on this calendar, Thursday, buffer day. What is buffer day? Buffer day is not a holiday. Okay, we're still meeting. I put buffer days every now and then in case I fall behind or we had to cancel class because of whatever. Okay, but we're still meeting. I was going to let that be a question and answer day. So if you have questions about anything from here, right, then Thursday is a good day for that. And then we take the test on Friday. And yes, we are having a holiday next Monday. Next Monday is Labor Day. We get the holiday there. So that's another good reason to have the test on Friday. Then we have a nice weekend. You don't have to worry about math for a little while, I suppose. Okay. Now, if I finish early and questions stop, I'll just get started with 2.1. Okay. So if I finish any of this early, I'll just keep going. But if you want to ask me questions the entire day on Thursday, I'll let you. But if you don't, then I'll just get started with 2.1 stuff, okay? All right, so we'll get started. The first problems here require us to look at the book. So I'll just look at the book. And you might recall at the end of Friday, I went through a lot of introductory stuff. And again, if you're not comfortable with memorizing some of that stuff, put it on your cheat sheet. You can have one cheat sheet, one sheet of paper like this, standard size, 8.5 by 11, front and back, put it whatever you want on it. Okay, so let me go to the text now. Okay, and yeah, I'm not sure if I did this before for you, so I'll do it again. So page 66, 1.5. So here's part of the 1.5 book. Let me try to aim it again. Okay, that's the top part, and there's the bottom part. Okay, then on page 67, keep moving it up and down for a better angle. And then some more. So that's up to about, what, 49-ish. And some more. And some more. Okay, so you can just, go to the video and move it forward or backward as necessary. And then on page 68, some more there. And some more there. And that should pretty much do it. Okay. So that's all the pages. Again, for those of you that don't have the book and don't plan on getting the book, then just do that. Okay, 3 through 12 all. I think we can just about knock them all off. Okay, so 3 and 4. A function is given by a table of values. Determine whether it is 1 to 1. Okay, now all of these are functions. So 3 and 4 functions. Any x gives you only one value of y. Okay, what makes it 1 to 1 is if there's no repetition of the y values. Okay? If any value of y would only go to one value of x. Okay, so notice for number 3, right? 1, 1.5, 2, 2.0. This is a function because it does not say 2, 2.0, and also 2, 3.0, right? That would not be a function. All of these are functions. Okay, this is a function because any x gives you only one y value. But it's a 1 to 1 function if any y goes back to only one x. So you're really looking for a repetition of the y values. And by the way, it says f of x, but you know f of x is y. Okay, so for problem 3, do you see any of these y values that are repeated? Is there a repeat in any of these? Yes, there is. 2.0 is there twice, right? So there is a y value, 2.0, that has two different values of x. So that means number 3 is not 1 to 1. So you can just put down in it's not 1 to 1 because there is a y value that goes to two values of x. Play the same game for 4. Okay, it's a function. Any x gives you only one y, but does every y have only one x? Which means look for repetition. Is there any repetition of the y values? Again, it says f of x, that means y. Or any of these repeated? It doesn't look like it, right? These are all unique. So number 4 is 1 to 1. 4 is a 1 to 1 function. Okay, any y value goes back to only one value of x. Okay, so again, 3 is not 1 to 1 because 2.0 is repeated, but 4 is 1 to 1. There is no repetition of the y values. Okay, and 5, 6, 7, and 8 are easy. Okay, it says they're functions. And by the way, do you agree 5, 6, 7, and 8 are all functions because all of them pass the vertical line test, right? 5 passes a vertical line test, so does 6, so does 7, so does 8. Okay, but now we're asking for 1 to 1-ness. So if a function is 1 to 1, it also has to pass, can you recall what line test for 1 to 1? It has to pass the horizontal line test also. Okay, so for a 1 to 1 function, it has to pass both vertical and horizontal line tests. So for number 5, if I draw a vertical line right here somewhere, right? It's going to touch in two places. So 5 is not 1 to 1, right? If I draw a vertical line like a horizontal line like this, it would touch in 2 points. So 5 is not 1 to 1. How about 6? Does 6 look like it's 1 to 1? Yes, it is. If I draw a horizontal line anywhere, it looks like it's only going to touch at 1 point. So 6 is 1 to 1. By the way, maybe I should have said it earlier, but you can abbreviate 1 to 1 like this. You want to write 1 to 1 like that. Save a little writing. 1 to 1. That's considered standard. Some texts write it like that. So 1 to 1, just 1-1. I'll let you write it like that instead of writing ONE-TO-ONE. Okay, 7. Is 7 1 to 1? Okay. Horizontal lines. Okay, 7 is 1 to 1. If I draw a horizontal line anywhere, it's only going to touch at 1 point. Okay, 8. Now 8 might be kind of hard to see, but it does kind of double back. It does go up and then go down. Okay, so it's a little bit hard to see, but 8 is not 1 to 1. It looks like if I draw a horizontal line right around there-ish. Okay, I can't show it to you with a ruler, but if you draw one maybe right up here, it's going to touch in 2 points. So 8 is not 1 to 1. Okay, then 9 through 12 requires you to know something about the graph, I suppose. Okay, 9. F of x equals 2x minus 3. What's the shape of y equals 2x minus 3. It's a line. It's a straight line with a slope of 2. So its shape is going to be something like that. So without graphing it exactly, does a straight line like that look like it's 1 to 1? Yes, it is, right? It's going to pass both horizontal and vertical line tests, right? So 9 is 1 to 1. Okay, 10 says x to the 4th minus 16. X to the 4th minus 16, well, crudely, x to the 4th looks something like that. Okay. Same general shape as x squared. And then do you recall what happens if I have the minus 16? What does the graph do? It goes down 16 units. So very crudely, something here. All right, so does this graph pass the horizontal line test? No, it does not. Okay, so x to the 4th minus 16, not 1 to 1. So yeah, you can write it like this for me on a quiz or test or homework, not 1 to 1, 1-1 is good enough, not 1 to 1. Okay, 11, 1 minus sine x. Well, if you just start with the basic function of sine, okay, I mean, we know sine goes something like that, right? So sine, does that look like it's 1 to 1? No, it's not. And it's not really going to change 1 to 1-ness if I do any. So minus sine x, that just reflects across the x-axis. It's still going to look something like that. And then the 1 means I move it up 1. It's still going to look something like that. So essentially, any sine or cosine function is going to look something like that. So that means it's not 1 to 1. Okay, so 11 is not 1 to 1. 12 says cube root of x. I'm not sure if you can see it, but do you recall cube root of x? So they have it in a book, but I'll just draw you a quickie reminder of cube root function. Looks something like that. Cube root of x. Okay, so does that look like it's 1 to 1? Yes, it is. Okay, so this one is 1 to 1. All right, so 3 through 12, we've literally done them all. It's all there. Let's see. 15. It's just knowing what inverse means. It says f of 6 equals 17. What is f inverse of 17? Well, f inverse just switches x and y. So f inverse of 17 must be 6. Right? So remember, all that f and f inverse do is they just reverse the x's and the y's. So f of 6 equals 17. Therefore, f of inverse of 17 is 6. Same thing for b. F inverse of 3 is 2. So what's f of 2? It's got to be 3. Right? All right, then let's see, 18. We'll do 18. I can aim it right. Okay, so it goes like that, looks like. Okay, A, why is f 1 to 1? Okay, 1 to 1. It passes both the vertical and horizontal line tests. So the answer to A, just put something like f passes both the vertical and horizontal line test. Passes the vertical and horizontal line test. And if you want some abbreviations, I'll let you do this. So horizontal line test. How about HLT? Okay. So if you put HLT for me, that's good enough for quizzes or tests or homework. Okay. And how about vertical line test? Vertical line test, let's just write VLT. Okay. So if you put VLT, I know what it means. You can just write that instead of writing VERTICALLINETEST. Okay, so horizontal line test, you may abbreviate HLT, and vertical line test, you can abbreviate VLT as far as I'm concerned. Okay. Okay, B, what are the domain and range of f inverse? Okay. You might recall we had that the domain and range of the inverse function are the range and the domain of f, right? So I showed you that maybe at the end of Friday's class. If I can show you that real quickly again. Yeah, here we are. Page 57. The domain of f inverse is the range of f, and the range of f inverse is the domain of f. And that makes sense because all you're doing is switching around the x and the y values. Okay, so all I'm going to do is come up with the domain and range of f and switch it around for f inverse. Okay. So let's do that. So for 18b, the domain looks like from -3 to 3 for x. So f domain is -3 to 3. Running it like that. And the range, let's see, goes from -1 up to 3. So f domain is -3, 3 brackets, range is -1, 3. So what about f inverse? You just switch them. The domain becomes the range, and the range becomes the domain. So the domain of f inverse is bracket -1, 3 bracket, and the range is bracket -3, 3 bracket. All you do is switch around the domain and the range. That's 18b. What is the value of f inverse of 2? Okay, so here's the logic this time. When we say f of 2, this says f inverse of 2, there's a -1 there. If it says f of 2, then you know that x is 2. Right? Like if I write f of 2, that's f of x, so x is 2. F inverse of 2, that cannot be x, so it has to be another variable. So what's the other variable? There's only one other variable, it's y. So when they say f inverse of 2, they're saying y equals 2. So y equals 2 over here, give me the x value. And it looks like it's going to be 0. So the answer to 18c is 0, because you're really saying let y be 2. If y is 2, then x is 0. Likewise for D, estimate the value of f inverse of 0. Okay, that's not x equals 0. If they said f of 0, they don't put that -1 there. If it said f of 0, then you're saying when x is 0, what's the y? That -1 means that you don't want x equals 0, you want y equals 0. So y equals 0, figure out the x. And I can see why they say estimate. You just eyeball it. It looks like -1 point, I don't know, it's more than halfway. Say -1.7 maybe. If you said -1.6, I'd accept it. But it looks like about -1.6, -1.7. Estimate the value of f inverse of 0. Okay. So I would say -1.6 or -1.7. Okay, so that's that. So I've just about done everything up to 18. Okay, the next batch, 21 to 26. So I'll have to show you how that works now. Okay, so let me show it to you in the text. Find a formula for the inverse of the function. Okay, so we had to do 21 to 26 all, I believe. Okay, so I'll show you the even ones. All right, so do you recall what happens for the inverse? You switch around the x and the y. So all that's going to happen is we're going to switch around x and y and try to resolve it for y and write the answer as f inverse of x. I want you to be able to write it as f inverse to f to the -1 of x. Okay, so 22, f of x equals 4x minus 1 over 2x plus 3. Okay, so let me show you how to do that now. Okay, 4x minus 1 over 2x plus 3, find the inverse. Okay, so the first thing I'm going to do is change this to y. If it says f of x, call it y. Maybe they already give it to you with a y. If they already give it to you with a y, then you're good. So y equals blah, 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 blah. And now just switch them. Switch x and y. Everywhere you see y, put x. Everywhere you see x, put y. So right there, change it to x. Right there and right there, change it to y. So now it says x equals 4y minus 1 over 2y plus 3. And now algebraically, try to solve for y. And then once you have y isolated, you write it as f inverse. So the final answer for these, always write f inverse of x, f with the -1 of x. Okay? So when it says find the inverse function, write it that way. Once you isolate the y, put the f inverse of x. I'll show you how to do that. Okay, so here we go. Multiply both sides by 2y plus 3. So it looks like this. 2xy plus 3x equals 4y plus 1. Or you can say cross multiply, right? That times that gives me this. Okay, then isolate y. To isolate the y, well, let's put all the y's on the right-hand side and put everything that doesn't have a y on the left-hand side. Okay, so y on the right, non-y is on the left. Now, could I move the 4y over here and move the 3x over here? Yes, you can, but that to me is not preferred. Okay? And the reason why I don't prefer that is because then you're going to have two negatives on this side. I'd rather not have too many negatives. I'd rather have positives. So I'm going to subtract 2xy, and I'm going to add 1. Okay? And then it's going to look like this. Okay. All right, so factor out the y. It's going to look like this. Y parentheses 4 minus 2x. Okay, then just divide both sides by 4 minus 2x, and you have it. Okay, so what I want you to write is y on the left-hand side usually. So divide by 4 minus 2x, divide by 4 minus 2x. So y equals f inverse of x. So I want you to write that is 3x plus 1 over 4 minus 2x. Okay, so this is considered the inverse function. So again, the original function was like that. Come up with the inverse function. So switch around x and y, and then resolve for y. Isolate the y. So we got this. Okay, and write it like this. F inverse of x, 3x plus 1 over 4 minus 2x. Okay. Okay, 24 says y equals x squared minus x for x greater than or equal to half. Okay. Right now, it's not sure what we mean by x is greater than a half, but I'll show you in a second. Okay, so switch around x and y. Everywhere you see x, put y. Everywhere you see y, put x. It's going to look like this, right? X equals y squared minus y. Okay. Now you say, how do you solve for y here? Here you have to complete the square. Again, remember that trick of completing the square? Take half the coefficient of y and square it. Okay, again, it's that half and square stuff. Half and square. So the coefficient of y is -1. So take half of -1. Half of -1 is -1/2. And then you square it. -1/2 squared is equal to 1/4. Okay, so I'm going to add 1/4 to both sides now. Okay, so after I complete the square, half and square, again, half of -1 is -1/2, square it, 1/4. So plus 1/4 on both sides from here, plus 1/4, plus 1/4. Okay, the reason why you do that, okay, is because if you do it the right way, this factors into a perfect square. The right-hand side is a perfect square. So what is that perfect square? It's going to be y minus a half square. So if you factor this perfectly, you end up with this, believe it or not. You can double check that. If you FOIL this back out, if you multiply that back out, you get y squared minus y plus a quarter, right? 1/2 times 1/2 is 1/4. Then you do the square root property. Okay, so you do the square root property. Ordinarily, you would have to do a plus or minus, but since it says x is greater than or equal to a half, the greater part means you want the positive, you don't want the negative. Okay, so I just have y minus a half equals that. Add 1/2 to both sides. So plus a half, it looks like this. So final answer, y equals f inverse of x, I want you to be able to write that, is 1/2 plus the square root of x plus 1/4. And that's the answer for f inverse. All right, so again, the general protocol for these is if you're asked to find the inverse, switch around x and y, resolve for y. Solve for y once again, if possible. Okay, 26 is a little bit harder because you have to do some natural log stuff because you have all this e stuff. Okay, 26 says y equals 1 minus e to the negative x over 1 plus e to the negative x. Oh boy. So how do I solve for the inverse there? Okay, so again, switch around x and y. If it says f of x, like this one, if it says f of x, call that y. But if I already give it to you with y, then it's fine. Just change x to y, change y to x. So wherever I see y, call it x. And wherever I see x, there and there, call it y. So I now have x equals 1 minus e to the negative y divided by 1 plus e to the negative y. And how am I possibly going to solve for y here? All right. So first, let's clear the fractions or cross multiply. Multiply both sides by 1 plus e to the negative y, or you can say cross multiply. So x times 1 is x. X times e to the negative y is that. So I have x plus x e to the negative y. Okay, next thing you want to do is get all the e to the y, e to the negative y's together, and everything else on the other side. So I'm going to add e to the negative y on both sides. That's what I'm indicating with this arrow. So that arrow means I'm adding e to the negative y, and there it is. And while I'm at it, I'm subtracting x. So I want the left-hand side to have all my y's, basically e to the negative y. And I want the right-hand side not to have any y's, so 1 minus x. Okay, so again, I add e to the negative y. That's what I mean by that. I subtract x. And I trust you can follow along that logic. Once again, if you were in my beginning algebra class, I wouldn't go that fast. But since you guys already know all that stuff, I'm just going to go straight to that. Now, factor out the common factor of e to the negative y. So e to the negative y parentheses x plus 1. Divide both sides by x plus 1. I'm going to write it as 1 plus x. It's the same thing, but this looks a little nicer. I mean, if this one's 1 minus x, I decided to write this as 1 plus x. You know, it's sort of nicer to have 1 minus x, 1 plus x. But if you leave it as x plus 1, that's also okay. Okay, so right now it says e to the negative y, e to the negative y equals 1 minus x over 1 plus x. See if we can aim it right. E to the negative y equals 1 minus x over 1 plus x. And yes, the whole idea is now I got an e. And how do I get rid of an e? With an ln. So I take the natural log of both sides. So remember, if you have e to blah, 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 get rid of the e with an ln. So natural log, ln, natural log. That way the ln and e cancel out. Okay, and a quick reminder, all graphing calculators or scientific calculators, e and ln are always paired with each other, right? So see here, my calculator has an ln and an e to the x right above it, right? So they're always paired that way. They are inverse functions of each other. ln and e. Okay, so ln and e cancel out. I just have negative y equals blah, 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 blah. So it should look like this now. Negative y equals ln 1 plus x over 1 minus x. And finally, just multiply both sides by negative 1. So if I multiply by negative 1, just put the minus here. So f inverse of x is negative ln parentheses 1 minus x over 1 plus x. Okay, that's the final answer. You could actually do more with that, okay, but I would accept that. That's an acceptable answer. Okay. In case you want to know what can I do more, and it may not match the back of the book, you could put the negative 1 up there. That's a property of logs. Okay, a coefficient can come up here, and then you flip the whole thing. Okay, so another acceptable answer is ln 1 plus x over 1 minus x. I think I'll just write that, but I'll sneak it over here. Ln 1 plus x over 1 minus x. This is also an acceptable answer. They might have this in the back of the book. Okay, how did I get that? I put the negative 1 up here. And if you raise something to negative 1, it means reciprocal. So I just flip it. Okay. Yes, this is considered a little bit cleaner. This is better than this because I have one fewer minus sign. So, you know. Do you have to do it? No. If you stop there, I would accept that. Okay, so those were the evens for 21 to 26. Okay. So now let's see, how far do I want to go here? 29. I'll talk about it, but I won't do it. I'll just talk about it. I'll show you the graph. 29. Use the given graph of f to sketch the graph of f inverse. Okay. So here's the graph. Here's all I would do. Take some key points, x comma y, just switch it. Switch it to y comma x. Okay. Now, this looks like the point 3, 3, right? 1, 2, 3, 1, 2, 3. What do you get when you switch 3, 3? It's still 3, 3. So 3, 3 stays on the graph of f inverse. Likewise, 2, 2, 1, 2, 1, 2. 2, 2 is still on the graph. So this little line segment right here stays the same. But you can switch this. So this is the point 1, negative 1. Turn it around, you get negative 1, 1. That's way over here somewhere, right? And what is that point? That looks like negative 1, negative 2, right? So negative 1, negative 2 becomes negative 2, negative 1. That's over here. So I would plot that point. I would plot, what was that other one? Negative 1, 1. Draw a line segment over there and keep that and just connect the dots. And that's how you would get the inverse function. Okay, so that's all. So it looks like you would plot what, that one there, negative 2, negative 1, and negative 1, 1, and just make it connect over to here and just keep this little line segment there. Okay, 31. Let f of x equal blah, blah, blah from 0 to 1. Find f inverse. How is it related to f? Identify the graph and explain your answer. Okay, so 31. All right, f of x is equal to square root of 1 minus x squared, and x is between 0 and 1. Find the inverse. Okay, so call this y. Y equals square root, blah, blah, blah. Switch them around, right? Everywhere you see x, put a y. Everywhere you see y, put an x. So x equals square root of 1 minus y squared. Solve for y. So x equals radical 1 minus y squared. Square both sides, get rid of the square root. Right? If I square here and I square here, it now looks like that. X squared equals 1 minus y squared. Add y squared to both sides. X squared plus y squared equals 1. I'm going to solve for y, but you recognize that? X squared plus y squared equals 1 is what famous graph from trig? That's our unit circle, right? Unit circle centered at the origin with a radius of 1. But we don't have the entire graph. Let's go ahead and keep solving. So move the x squared over, subtract x squared. Y squared equals 1 minus x squared. Take the square root. We don't want plus or minus. Okay, the original was only positive. Okay, here y is positive, x is positive. So I only want the positive. So y equals f inverse of x equals square root of 1 minus x squared. Okay. That is the answer, but do you notice anything about that answer? It's the same as the original. Okay, so we have an example of a function which is its own inverse. The inverse of the function is itself. Turns out to be itself. All right, and if you stop and think about it from what we said earlier, that actually does make some sense if I think of the graph. Okay, so what did they say? Identify the graph and explain your answer to part A. Okay. Well, I had a unit circle, right? So if you will recall, for a unit circle, I'm going to go all the way around, but since it said x is greater than or equal to 0, y is greater than or equal to 0, I only have this. Okay, so the rest of the circle, I'll just kind of dash it, meaning it's not really there. Separate all this other stuff. So the only graph is here. And you might recall we said earlier that the inverse of a function reflects across the line y equals x. Let me see if I can find that for you again quickly. Page 59. The graph of f inverse is obtained by reflecting the graph of f about the line y equals x. So they're showing you a picture there. And here's a picture, right? The reflection of the blue across the line y equals x is the red. Okay, so if I do that for this particular problem, y equals x, we know goes through the origin, 45-degree angle. Okay. But notice if I reflect across the line y equals x, they're already mirror images of each other, right? The mirror image of this part is this part. Okay? So we basically get the same graph all over again. So yes, it is possible for a function to be its own inverse. So in this particular case, the function is its own inverse. Whoops. From what we have over there. Okay. All right. Okay, then what time is it? Just about out of time. I'll show you one thing about logs maybe, and that's about it. Okay, so see how far have we gotten. We have to do 35 to 42. Okay, some stuff about logs. Find the exact value of each expression. Okay, so show you one or two of those, and that's about it. Okay, 36A. It's a log base 5 of 125. How do you do that without a calculator? Okay, so call it x. So log base 5 of 1 over 125 is equal to x. Okay, now unscramble it, write it without logs. Remember from your pre-calc, you take the base, you go across the equal sign for the exponent, and you come back in for the result. So it's the same as saying 5 to the x equals 1 over 125. Okay, so again, call it x, unscramble it, start with the base. Exponent is across the equal sign x, come back in for the result, 1 over 125. Okay, then from there, I want to rewrite it so that the right-hand side has a base of 5. Okay, 125 is a multiple of 5, but it's in a denominator. Way to get around it is to write it like this. 1 over 125 is equal to 125 to the negative first power, right? So I write it like that. And then I say, how can I rewrite 125? Well, 125 is 5 cubed. Okay. The reason why I want to do that is I want the left-hand side and the right-hand side to have the same base. Okay, so I know 125 is 5 cubed. So 5 cubed, that's 125 to the negative 1. So this still says 125 to the negative 1. And now we know that we have a property of powers, that if you have a power and then another power, you get to multiply the powers. So 3 times negative 1 is negative 3. So now I have 5 to the x equals 5 to the negative third, and that's what I want. Once it looks like this, you can just look at it and say, oh yeah, x equals negative 3. Okay, so that's how you do that. So remember, that's how you do some log problems. Okay, then B, and I'll stop. B says ln of 1 over e squared. Ln of 1 over e squared. So the trick is to write this as e to the negative 2. 1 over e squared means e to the negative 2. And then I want ln of e to the negative 2. Well, anytime you have ln and e back to back, ln and e, or I might say e and ln, they cancel out. So the answer is just negative 2. So there we go. The answer is negative 2. Okay, and that'll do it for today, folks. So I'll make this disappear. Stop share, stop recording. I can find that out. Okay, let me check.